到时候这个倒计时好了，我们就会放视频。他要黑屏，你注意他黑屏，你拨一下这个感觉就行。然后就兄弟，哎，太帅了，对，比较好。然后这样做这个可以做，你要调高度，直接把这个松的这个松。如果前面有人挡住，你就把这个给弄松，把这条弄松，然后再把这个升松，到合适高度再。
是到10点半。是好像只需要我交2节，就可能把我推升有点不太错。他不3节。嘿。那他是7节的话，还是在下面有些。
我本来想用那个但是就是第1个礼拜的周3什么的，后来不能用起来，
那个房间在哪？
就是3楼一个很大的健身教室，然后拿了一个。小一点嘛，但我不能每节课都打这个。然后我跟他说，我洗每节课礼拜3过去，
所以你本来是做不是花活的，
前面几个
可以看7你分享应该是这样的区域是。 这个 PDF 的视觉可能就不转，因为它会秀一个，然后这种去历史，然后下一句话就是 hypothesis， 这就别的时候
知道
Oh, really?
它是我们自己的习惯。37就已经非常的，
Nice person.
它就是一直在深入上面。当时因为是这个它是但是大家学生很多都是这样，但是外部的话，通常是大于30，更少一点。这样那真是人家不少。
Well, no, you can use PowerShell on those. Yeah. Actually, like Python shell.
上次来。他可能这个星期。我从那个上面然后他们中国老师的话，但是上来就上来我的训，然后我1个月教，
Shell like stuff. Like Python execution and stuff like that. Yeah. The script, I don't understand that very well. It's really complex.
Yeah. Finish that. Yeah. So that's the good.
You have to do a PhD.
Okay guys, settle down. Let's start. Yeah, so on. Guys. So on Tuesday we have covered relational algebra and now we will be starting with SQL. So yesterday on Tuesday we have started with SQL and we have just covered the first slide, that is the how to create the table and what are the column constraint and table constraint that we will cover today. So let's start with that. So on that day I also talked about the data types of the SQL. So we have the character, variable character, the numeric, date and the serial of the unique ID. Okay. There are many other based on the different databases that we have. There can be many data types, but broadly they classify into these 5 categories or something. Okay. So you might have a question that why do we need character, that fixed length character? Why do we means if we have a variable data type, right? So if you specify like this, that char 20 and char 20. So this means that it will occupy 20 bytes of space at the data frame. Okay, and this says that it can at most take 20 bytes in the data frame, in the data storage engine, right? So mostly if you just think about the names, right? That your name you have. So if I just draw the distribution of names, say this is the count and this is the length of name. Okay, so you will find that it will be like this curve and which goes on. So this is the long tail. And so most of the people falls in this region. So very few people have their names that's very short, like 2 digits or 2 bytes or something, right? 2 character or something or 3 character. But most of them falls within say 5 to say 14 or something, right? So if we have characters 20, then we'll mostly use most people will have their name within that 20 character. Okay, but we won't be able to cover this many. But if most people is the mean, if say is 8, so we are wasting 12 bytes right over there. So for most people, so we are taking 8 bytes for the name, and this 12 bytes is not there. So we are wasting many spaces. So over that we can see that varchar, where if I write just name of Felipe, so we have 6, 1, 2, 3, 4, 5, 6, and there will be null character. So it can at most take 7, right? So varchar will take 7 instead of taking 20 in the fixed digit. So with that we can see that varchar always is a winning situation, but it is not actually the reason. If we see how we manages the database kernel, okay, when we will teach that how we construct the data frame, how we do indexing and all those stuff, that time you will realize that how this fixed length can be of advantages. Okay, so that's why we have this fixed length also, and also this varchar. So if you just see, we always denote our department names with some aliases, like computer science as CS or something. So they have this fixed character. Within that you denote your enums or something. If you know computer means, if you know programming, you know what is enum or enumerated. So at that time we try to have the name shortened and make some aliases which can be denoted as with fixed length character. So that's why we have something like fixed length in the databases to get the power from the storage engine that we can do indexing on such stuffs. Okay, so you will learn that later. So these are the 2 things that I have to mention over here. Now let's come to the column constraint. So I'll first dive into example, and then, so the difference between the column constraint and the table constraint is that you specify the column constraint just at the side of naming a column. Okay, so if I have an example over here, okay, let me create one. Yeah, so let's say create table and say person, and I start with say ID. You have to specify what is the data type. So this is the name, this is the data type. Then you specify the constraint. Say I am saying not null. Okay. So this is one of the constraints, and maybe we can do something like this, that let's specify name, and name is say varchar 20. So and age, and it's integer, and I specify and within parentheses I write age between 0 and say 150. Okay. So this part, this is the column constraint. I wrote that part just after specifying the column and the data type. So and you can write many other things like after you specify all the columns, you can write the table constraint over here. So why do we need column constraint and table constraint separately? Suppose we have a table where you want to specify the primary key with 2 columns. You can't specify that over there. So if I just say id int not null primary key, this is okay with the column constraint. Okay. But suppose I want to create a table with that look like reserved, where I have SID and BID, where and date, and I have this SID and BID. Those two are itself combined, both those two make the primary key, right? So I have to specify this one as a table constraint, not the column constraint. Okay? I'll show you one example with the column constraint. Let me do. By the way, you all will have access to a particular database table where there are some data based on this CS6530. So let me just. So this is how you can see what are the databases that you have. So you will only have access to CS6530DB and maybe also this Sakila DB. Okay, and so you can try your examples over there. We by the end of this lecture will give you the credential to enter this MySQL database so that you can play around with that. Okay. So now let me use so show tables. So there is no table over there. I'll just create a one. You all can see that. Okay, yeah. Create table. Say persons. Start with ID int. Then name property age int. Now as a column constraint, I want to make a check that constraint, and you have to specify the constraint name. So age j, and I'm checking that age is between. So MySQL is actually case insensitive. Okay, 0 and 50, 150. And just have to specify the primary key ID. So I have created a person table with a constraint that the age should be between 0 and 150. Okay, now see the thing over in MySQL. So I should be able to insert. So I should not be able to insert this value, right? So John D, it has, okay, I don't have department. Name manage. I should not be able to insert this value in the MySQL, right? But I haven't specified as auto increment. I'll also show that. Let's say I have this value as 30. But it actually inserted. It's weird, right? So let's do select star from persons. So something should be wrong with that, right? The syntax is right. Even if you just do the describe persons, it doesn't show anything extra over there. There is no constraint over there. So that's not the fault in us. If you just do the same query with PostgreSQL, it will work. Okay? It will not allow you to insert that data. It is the fallacy of this MySQL database. If you just, I'll just show you this. So check constraint in MySQL is not working. Actually, in MySQL reference, this says that the check clause is first but ignored by our storage engineer. Okay? So this one works with PostgreSQL, but this one doesn't work with the MySQL. So for that, you actually need trigger kind of something. So in the last 2 slides of this presentation, we have something about trigger. You can use that trigger method to implement that in the MySQL. MySQL, to maintain the SQL standard, they just incorporated that check statement, but they don't do anything inside. Okay? Now let's come back to the presentation. So another thing is that we have this reference table, reference column on delete action. So what does that mean? So when you have something like student and maybe a department and list of students, say. So you want to remove a department from it, so it's not too often happen. It doesn't happen so often, but maybe for some reason you want to stop a department or maybe a part of the department, or you want to eliminate a course or something. So when you eliminate a course, so you have a course ID associated with that, and also the number of students with that. So you have the referential integrity with the course and the student ID, right? So if you want to remove that course, then you have to also remove all the students that is referred. You can have them in the table just to make sure that is there. So in that case, you usually do no action. So reference table. So I'll do maybe from the course table. I'll do course. I'll create a course table with reference to the student ID table, and the column, that is the student ID, students table and student ID, and on delete action, I can either choose no action, cascading delete, or set a null value for them. Or if the table has some default value, maybe 0 or something, you can set that. Okay? So in case of no action, if you delete that course row with the ID, it doesn't affect the other table. If you do the cascade, when you delete that, the other rows in the other table that is reference to that will also be deleted. And for the set null, we'll just set null values for them as the course ID. Okay. Now coming to the table constraint, I'll just go with this particular example. There is one example of with this one, the constraint production. Okay, let me talk about this unique thing also. So here it says unique date underscore prod. So there is an attribute date production with date. It says that for this particular table, all the rows that has the date must be unique. They must be a set. There can't be two values with the same date, two rows with the same date. Okay? Got the point? And here is this constraint foreign key date reference distributor on delete no action. You can just specify over here no action to cascade delete or something like set null or set default value. Okay? And here is something that uses the table constraint. See, we specify this one at the last. So these are the examples of the table constraint. And over here, there are two things, DID and name. So, what is the constraint? That I should have the DID value greater than 100 and name should not be null or blank. But this one we can rewrite with column constraint, right? Because there is an AND clause. So AND clause can be subcategorized as, so DID I can do check with DID greater than 100, and also for this name it should not be null. Then I don't need this part. But if I do odd over here, then there is a problem, right? At that time, you can't have the constraint over here if you just have the odd over here. So there is an exception you are making, that if my DID is less than 100, the name can be blank. You got that point, right? At that point of time, I need to check both the statements, both the values of the DID and the name over there. So if we have a condition like all over there, we have to specify in the table constraint. Okay? And let me show you another thing. Let's say drop the table. Yeah, so let me do this one. So I am adding a auto increment, and this auto increment could only be present with the primary key in the MySQL. So this is one of the constraints with the MySQL, that you can only have the auto increment with the primary key. So that's why I need to explicitly mention that primary key is ID. Okay? And so MySQL is case insensitive, so if I write that ID over there in caps, it doesn't matter. So now just insert one record. Okay, so what do you expect this results ID will be? It will start from 0 or 1. Okay, by default in MySQL it starts from 1. And one more thing, let's say I insert another value. Okay, so now it will be 2, but I want to see what is the next value. Okay, so select last insert ID. So this is one of the function that is used by MySQL to see what was the last insert ID for a particular table. Okay, we can otherwise use this kind of thing also. Show table status from, so this is my database name, where name like person.
From the button.
Oh, yeah. No? I think, let me check one thing. Show table status. Let me just yeah, it's not done only. So table status. When name equals to persons. Okay. I can see that. Let me. Here is data name, index name, auto increment. So there is this auto increment field over here. Okay. So this auto increment field, this one corresponds to this one, this 3. So the next value, it will be this 3. Okay. But in MySQL we have this value attached to a particular table. But in PostgreSQL we have a concept of sequence. So in sequence, so there is a variable called sequence. You can specify that. In MySQL also there is a sequence concept, but it is not used much often. But over there we can specify that this is my sequence that is used with a particular table. Okay. One of the thing that another thing I'd like to show is, let's delete. So let's start from persons. Now let's delete from person where ID equal. So if I insert another value, another row over here, what will be the ID? Will it be 2 or will it be 3? Why don't we, okay, let's do that once. So now it's 3, but it could have used that, means recycle that ID, right? Why it doesn't recycle that ID? Anyone? Means MySQL could have recycled that ID too, right? Any reason? Anyone? Yes?
Because the ID was all incrementing.
Yeah, but it could have used that one, means it can go back because it knows that that record is not there. So it could have used that, right? Yes?
Because maybe in some other tables there will be some records referenced to this record.
Yeah, exactly. So the cost of implementing that thing is much more, because you might have a dependence of this table to another table, and so for that reason, if you just specify 2 over here, you might need to change the other table. If you see, the last time I talked about the cascading effect, right? So if you just do no action on that, then that ID will be there in the other table, that 2. So it will wrongly reference that one to that one. So this 2 and that 2 will be different. So if I inserted that ID 2, I made some changes in the other table with respect to that row, and then I came back, I deleted that one, and I reinserted this one with ID 2, it will all be messed up. Okay? Okay. So this completes almost the DDL part, data definition language. I will start with the DML, data manipulation language. So this select star from student is where age.age is 18. Okay, this can exactly be expressed as the relational algebra. So relational operator. So you are selecting oh, you are not projecting actually, you are just selecting age greater than equal 18, and this is from student. Just ignore that S at the side of student, okay, for now, because I haven't come with a range variable. But if you just do select S name and S login, then you need this projection of S name and S login. Okay? Now let's quickly go through the just look at this 2 table and this node. What does that mean? Means you all have almost covered that thing in the undergrads, that's why I'm just taking a bit more time to so that you can just understand the things that are there. Anyone? Why it says that obviously no differential integrity constraint have been used here by saying this today? Anyone? Suppose this is the all data that I have. This is table 1, this is table 2, and yeah. So this SID and there is SID, right? Just think of the thing that I specified a minute ago, just a couple of minutes ago. So you can see 53688, is that present over here? No, right? That says everything. That with the referential integrity, you have to have something with that value. Okay? That's all. Okay. Let's So we can have the where condition with multiple clause. So we have and in between. So that's the expression, Boolean expression again that we do even for the relational algebra operator for the selection. Now there is a specific way that we can interpret, means when we translate this equal to a particular relational algebra. Okay, so whatever that comes at that after form, that's the relation list, that can be exactly represented with the Cartesian product. So everything that relation list have. So suppose relation list have A, B, C, these three things. So I will have A cross product B cross product C. Okay. Now where is the clause? So I can put selection and the condition over here. Whatever the condition is there, the qualification, condition or qualification. And there is this target list, which is exactly the projection, right? So this is target list. We have a distinct operator over there, so that it does exactly same as the projection. Why do we have, means why by default it doesn't, the SQL doesn't act like the projection? Any idea? Means it could have done that thing by default, right? There is no need to have that distinct operator. So if there are multiple rows which has the same value, it can just make it a set and output it. The reason is that the operator of deduplication is expensive. Suppose you have million records, and in that just means the output is million records, and inside that if you just parse that whole million values and just find the deduplication, it can be little means costly. Unless the user specify that, you don't need to do that. That's why we have a distinct operator. And even in some queries, it makes sense just not to have the distinct operator. We'll see that in the later examples. Okay? So that's the advantage of doing the SQL. So that is the difference between relational algebra and the SQLs. Okay? So you have to explicitly say distinct to remove the duplication. So this is exactly what I said. So we have this two tables. We are doing the cross product because there is a student and enrolled that is specified with comma. That means these are the relation list. Okay. So by default, it does this Cartesian product. It outputs this intermediate table. You apply this where condition. That's exactly how it's specified here, right? The steps, and then it projects that. So over here, I did the Cartesian product. Now I am doing the selection. So s.sid is equals to e.sid. When it is matched, I disregard all the other rows, and then I select only the s name and e.scid. Okay. Okay. Now let's come to the example schema. And the join query. So till now I haven't specified anything about the range variables. So when you specify something like this thing. Select S name from sellers reserve, where sellers.sid equals to reserves.sid. Till now I have written this one like sellers as S and reserve.s. So these are the range variables. These are the range variables S and R. Okay. Why do we use that? We use that to simplify our query language, just to make it shortener. And there is also another use case is that when you do self join. Okay, I'll explain that just a bit afterwards. So you can always specify like that, the first one, the prior one, if it is means it is more sensible actually if you just write that one in that fashion. Sometimes you will also find that in industry that they use the full name, they don't use the aliases. Okay, because when you write a query and the another person that comes in place of you in a company, he has to go through all of that aliases to make understand what is that. Okay, so they usually specify to write in a full name, but as a student or you can write that with the range variables, and also the range variables sometimes make much more sense in the self join or when you are writing something inside as a nested SQL statement. Okay, we'll come that one just a bit afterwards. Yeah, so there is an example of the self join. Select x.sname, x.xage, y.sname, y.age. Okay, let's see what exactly this one does. So we want to make a pair of sellers with one seller who is senior and one seller who is junior. Okay, we want to make pair of those sellers. So yeah. So for that we need two instances of a seller table. I can't specify a seller table sellers.sellers. That will give us an error. Okay, so we have to rename that sellers, create an alias or the range variables to x and y, and then from one copy of the table I select the persons who has more age than the other in the second table. So in that way I can combine any seller who has one of them where one of them is senior and another is junior. Okay. And the later one is that you just want to emit everything, then you just use star. Okay. Now let's do this one. Find sellers who have reserved at least one vote. So anything that is there in the reserved has a SID associated with that, right? A seller has reserved the vote. So that's why I can just compare s.sid equal r.sid. But is this statement correct? If I just have SID, s.sid, will I get all the sellers or do I need to do anything extra? So suppose a seller has reserved a vote multiple times. Suppose seller S1 has reserved vote 103 3 times. Then that S1 will come thrice, right? So if we just add distinct on that SID while projecting, we'll get exactly who are the sellers that have reserved at least a vote. It don't show S1 thrice, right? So that's why you need distinct over here. Okay? And what if I just change that SID to s.name and use distinct? So select distinct s.name. Will that make sense? Anyone? You understand? Yeah.
Many sailors can have the same name.
Exactly. Many sailors can have the same name. So I might lose some information. Okay? We can also specify the expression while doing projection and also in the where clause. So these are the mathematical expression we can add with them. There is 2 multiplied by s1 dot rating. There is minus 5, s dot age minus 5. Similarly, you can actually do comparison with one attribute to another attribute. Say current date minus date of birth. You can actually get that one as that age, right? And this as variable is exactly as the this one is the rename variable, renaming operator. This as. Over here for string operation, we can use either underscore and percentage just to select the names. Okay, so this underscore is exactly one character and this percentage stands for many character. It can stand from 0 to multiples, any. So if I just specify s dot name like j underscore percentage m, so it should actually have j, at least a particular character in the middle, and then m, at least a character, because we have underscore in there. So if you have idea of regular expression or something, or automata, you can just write it as something a plus. So plus denotes that you have at least one a there. Otherwise you write it as a star, right? That you can have at least 0 or more than one a. So percentage star stands for star, and if you just have a character underscore with that, you can just express a. But yeah. Now we'll come back to the one. Yes.
Is there any like performance advantage for why I guess they do like underscores, like I guess this kind of variant, kind of almost irregular expressions versus just using regular expressions?
Internally they use as regular expression.
Okay. So
it's based on your storage engine. It's how you want to do that.
Okay.
So the one that you will build with the in this class, it might not have that storage thing. You can actually build that, and you can use either regular expression or a normal kind of algorithm that you can with that. Okay.
Okay.
So it's very specific with the database engine, that how you want to manipulate, how you want to execute that function.
I was
Yes.
just wondering in the SQL standard if they've limited it this way with a light command for performance
So
reasons.
SQL limited it with the underscore and this thing, but internally how the function works, that is up to you. That is up to the database, right? SQL is just the language to with the interface with the user and the database.
I was just wondering if databases have done some sort of optimization there versus just using regular expressions.
They could have, yeah. So it's based on the database engine, and every database has their own engine. Okay. Now let's do this thing. So we have covered this same expression in the relational algebra, and there you have used OR exactly like that. You can just specify OR over there exactly, but you can also have union. So the sailors we have reserved either a red boat or a green boat. Okay. So we can actually specify that one over there as OR. But same goes in the next, that can we specify with the AND. This doesn't happen here, right? if this is and, this is again wrong. We used intersection over there, but we have used intersection over there, but we can do something different also over here for the sequel. So this is wrong. Let's look at it in this way, that we have two copies of board and reserved. So we have board 1, reserve 1, board 2, reserve 2. And from one of them, from one copy, I want to take out the green one, and from the other copy, I want to take out the red one, and then match their SID. So this part is used for join. Is R1, B1, R2, B2. This part is just used for joining those two copies, right? Then from B1, I just selected the red ones, and from B2, I just selected the green ones. Then I try to match them over there, that R1.SID is equals to R2.SID. Okay? So I am just creating two instances of the same thing just to do this one. You can have multiple types of thing over here, means you can try different expression, but anyone has question on that? How we have derived this one? So we have two copy, board 1, reserve 1, board 2, reserve 2. These two, then we join both of them, make the bigger table, and then from one copy we select the green ones, other we select the red ones, then we map the SIDs. Okay? In that way, at last we can just project one of the SID, because R1.SID is equals to R2.SID. So I just projected one of them. Okay? Can I do this one like this? Select R2.SID from board 2, reserve 2, and just select the green ones as green. This is much more simpler, right? Yes. Thinking wise. So this is the part of this block. This is a SQL block that actually emits a relational, means a table almost, and an intermediate table or relational instance. And I named it as green, and then from that green table I try to map the ones with the red ones. I can do a little bit more. What if I just do red ones and the green ones, and then just map the SID? This is also same. See? So I can rewrite them as partial block, partial SQL block, and then evaluate them. So they are the intermediate table, right? And anything with the parenthesis, they must qualify a SQL statement. Select R1.SID from this to the and something as RR. So this is one of the renaming operator is taking place over there. So this is also why our renaming is actually important, creating the range variables. Okay? So over there we could have used the intersect, but some of the databases allow intersect, but it is not a elementary operator in relational algebra. So they might not implement that. Okay? In MySQL there is intersect, but you might be using any other databases. They didn't implement intersect. So at that time you have to do it in the formal way. But you can take the leverage of the intersect. Okay? So the databases will have except, but they might not implement intersect. You can also take the advantages of that except, that means minus, of the relational algebra operator. If you remember that intersection is A minus B, right? You can use the except over there. You have this part, you do this part except, and then just instead of doing that intersect, you can do that. This A intersect B, instead you can just do except, and then again write that same sequence part and do except. Okay. So find SIDs of sailors who have reserved a red but not reserved a green code. Here comes one thing, that we can use the minus or the except. Who has reserved red but not the green code. Okay? So this but did not. This part is important. Make sure when you have the exams, if you find that but did not, then you can think of this except. Okay? I'm pretty sure that when I was taking this class, he gave this kind of query with, and that was pretty complex. Not just but did not, it has something else with that also. It was pretty complex query. Yeah. Now we'll start with the nested queries. So, name of sailors who have reserved board 103. That was very simple statement when we did that in slide 9 or something. Okay, but over here we want to get the names of the sailors who have reserved the board 103. Over there we have done the join of sailors with the reserve. Okay, what we want to do over here, we are using a in operator which internally has another SQL block where it is evaluating the seller's ID or getting the output as the seller's ID who has the board reserved as 103, who has reserved board 103. So there can be multiple elements or the multiple values over there, right? So we call it as a multi-set. We call it as a multi-set. And if we use the in operator, it will just, so select sname dot from sellers s where s dot id, it will parse the whole sellers table, and for each of the sellers s or each of the seller, it will try to find out this expression. So this part is the dynamic one. For each seller, it will evaluate this part, okay, and then it will see if that matches with that. If that SID is within that expression, that evaluated expression, okay. If that matches, then it outputs. I can just do not in, then it will be who have not reserved 103. Okay, so if you just think of the statement that I have, the query about that, the sailors who have reserved board 103, that is very simple. Then you just change that, the sailors who have not reserved board 103, then this is most efficient way, just to use not in. Okay. So if you have not, You can either do it in this fashion, or you can just do the older one, but it will be little bit complex that you have to find all the sellers that is not equal to 103 and then join. And this is how you do nested loop. But these two statements over here, the first part and the second part, they are independent of each other. We will see a case where this can be dependent. Now let's do one part. Let's say this one. Find names of sellers who have reserved port 1 or 3. If you remember the previous one and this one, there is a change. It says that where exists. And I will say that this is much more efficient query than doing the not in or in operator. Because for every particular seller, so when I write the first part, what it does is that it goes through each and every seller and project and output this internal part. This part is dynamic based on the SID that I have in the first part. It matches them. If it is there, if the set is not null, means if something is there, then it outputs that is. So these two things is not independent, they are dependent. Similarly, exist is for, so if we have something like exist, okay. So exist, they always outputs true or false, okay. Even in the condition of in, you just look at the multiset that say SID, you see S1, S2, S3, you check if any one of them is equal to this one. If SID is S1 for that instance, you see that whether there is S1 or in that whole set. If I say, if I have S4, then this value is false. Then the outcome is false, right? Over here, exist means if there is something within that block, if this part is at least not null. If it is not null, then it goes true. So not null, and if it is null, then it is false in the exist. So if I just change this part again, let me just do it here. Unique. So if I just change that one to unique, then what will be the So if I just use unique, how the query changes? What is the query now? What it outputs? It becomes that, and let's just change that start to r.bid also, because otherwise it won't be. Let's just do it as bid. Okay? Bid. So unique, and we change that to bid. Now it becomes the sellers who have reserved port 103 one and only one time, only once. Because if you just think of this one, if if the seller has reserved this boat multiple times, then this BID will come multiple times. It won't be a set, and for becoming a set, one element should appear only once. So that's why we have this unique. That means that this part should give us a multi-set. This gives us a set, not multi-set. Okay, this gives us exactly set, not multi-set. But if I change this BID, if I just change this BID to something like distinct, then I am already eliminating that thing, that multi-set, the probable condition of being a multi-set is reduced to a set, because I am already doing that distinct. So it is again same as that find names of sellers who have reserved port 1 and 3, because I am explicitly doing that distinct. If I just don't do that distinct, it will be the sellers who has reserved the port once and only once. Okay? So there is another type of multi-set operator that is called any and all. Okay? I'll do a demo of that maybe. Say, so over here, what is the query? It says find the sellers who has a rating at least, find the sellers who has the rating at least greater than any of the sellers greater than the seller rating of Horatio. So whatever the rating of Horatio is, I want to find the rating of sellers who has more than Horatio. The name of the sellers who has rating more than Horatio. Okay? So if seller Horatio has, say, suppose rating of 5, I want to find any seller who has the rating greater than 5. Okay? Let me show an example of that over here. So there is a database Sakila that is so Sakila DB. So this is a sample database that we have. It's a standard one for doing all this thing. You can see the structure of that over here. Okay. So I'll just play with the payment one. There is something like payment. Let's do that. Show tables. So there is something like payment, and I want to find the people who has made a maximum payment at a particular transaction. Okay. So I will have to use all. So we have this amount. So I am selecting a customer ID and the amount from payment, where amount is less than or greater than greater than equal to all select amount of payment. Okay, so this part will give me all the amounts of the payment, and from that I want to select the ones that has greater than and equal to. What it will give me? This gives me exactly the customer IDs who have made the maximum transaction amount. Okay, if I just change that to less than, then what it will be? It will give me all the payments that is not equal to maximum. So all the payments that is just below the maximum. It has all of them. Oops. Sorry. Any. Then I'll have everything just below the maximum, less than. So in that way you can actually, so if you remember or if you have seen the slides in the last relational algebra, there is a particular query where we want to find out the highest rating of a highest rating of a seller. Name the sellers who has the highest rating. At that time, what we did is that we did the disqualification of the sellers who has less than, and then we did the minus of that to get the sellers who has the highest rating. So this part is actually the disqualification part. If you just use less than any, okay. And if I want to find out the minimum, I'll just use less than all. So this people has made 0 payment. Okay. So just to give an overview of this part. So V in A, where V is a value and A is a multiset. So A is just within the parenthesis, that equal block that it outputs. And so V is not in A, then I get false. Otherwise, if V is in A, then I get true. Exist if and only if A is not null, then I get it as false. Exist, yeah. If it is not null, then I get it as true. And if it is not exist, that means if it is the set is null. Okay, there is nothing in the set. That's why I get it as false. Unique if and only if A is a set, that set is important. That is not a multi-set, that is set. Okay? And V operation any. So I have a greater than or equal to operation over there. So this OP stands for any mathematical expression. Any evaluates that at least it should be true for any one of them. And for all, it should be true for all of them. Okay? I'll just try to quickly go through at least division today. Yeah. Okay. Division with sequel is a little bit tricky. Again, we have to use, if you just remember the last lecture, we have used the disqualification of elements to find out these sellers over there. So, what we are doing, find sellers who have reserved all boards. Again, that all comes, right? All. So, select is name from seller is where not exists. So, there is two not exist. This is pretty complicated query. So, before I just go through that, I'll just tell you the basic principles. There is a double negation, okay? Not exist and not exist. But if you remember the ones that we have said while doing the relational algebra, that we try to find out the ones that doesn't qualify. Okay? So find out the ones. So find out the seller who has reserved at least a vote. So, So who have not reserved at least one vote. the sellers who have reserved, who have not reserved at least one boat. His or her name should come over here, or that boat ID should come here that the seller has not reserved. That is the main inclusion of this block, this bigger block. So let me draw it. Okay. So this actually means sellers minus sellers who has not reserved at least one vote, right? This part. So if you see this part, select R dot PID from reserve R dot PID and B dot PID. So it exactly says what are the boards that seller has reserved, right? What are the boards that seller has reserved? And I just use this S dot SID from that part, from the top. So it is always a dynamic statement based on that particular seller that I have selected. So I get all the reserved board that the seller has reserved. Now see, it says that not exist. If this statement is null, this part is null, that means this part is empty, then this part becomes true. You got my point? So for any particular board that has not been reserved over here by that seller, it will come over there. So if a seller has not reserved a board, that will come over there. And again I do the not exist. So if I have at least a board that I have not reserved or the seller has not reserved, then it will again become false. Then that SID will not come there. It's little tricky, but make sure that this block, this full block, it executes what? That the boat should not appear here. If the boat appear here, that means the seller has not reserved that. Okay? It is exactly this part. Sellers who hasn't reserved at least one boat. So seller is such that there is no boat without a reserve tuple showing S reserve P. This is a little bit complicated, but what I mean is that if this part is null, then your results come over here. And for that part to become null, you have to reserve all the boats. If I reserve all the boats over here, this will become null, this will become true. Anyone has any question? Yeah, you need to just go through the slides again after going home. Yeah. But make sure that this part is the same as the disqualification rule. Okay? So we have your aggregate operators. Because I told you about that trigger part, I'll just tell you about that one in a moment. So let me just go to the last slide. triggers. So trigger is a daemon that is attached with the databases such that when an event occurs, it actually executes that part. So see this one, create trigger minimum salary before insert on professor. So when I do a insert statement on professor table, it has to make sure that this when condition, new dot salary is less than 100,000. So if a professor's salary is less than 100,000, then it will say here the violation of minimum professor salary. So in that way, actually, you can do that check statement in MySQL. Okay. Okay. With that, I'll end today's class, and Fefe will cover the aggregate part. Okay. Thank you so much.
在那个